All right. Good afternoon, everybody. Are you there? Good afternoon. Can you hear
Good
me?
afternoon, sir.
Right. I trust we're all doing well.
Good afternoon.
Yes, please.
Great, great, great. I want to welcome you all to today's class. And can we invite the others? Can we remind them to join in? So far, I can see about 34 people here. I can see only about 34. And then whilst you remind them to join in, I want to ask whether you have access to the recordings that have been done so far. Do you have access to them? Hello? Please, do you have access to the recordings?
Yes, please.
Yes, sir. Yes, sir.
Okay, including even what I did, the extended version of what I did. Remember, we couldn't finish off everything and I had to do extra recording. I want to believe that you have it. Okay. Do we allow a few more minutes for others to join? 4 minutes. So we start at 1:35. Is that okay?
Yes, sir.
Yes, sir.
Very
Fantastic. All right, so we have 4 more minutes. All right, thank you. I'll mute up for now. All right, so I guess we can move on because we have allowed enough time to wait for the others. There was a question that was asked last week.
Say, I like your car.
Thank you very much. There was a question that was asked last week. I don't remember who asked that question, but I believe it was a lady that asked that question. She asked the meaning of because it's not my main slide, I just want to respond to this question.
The cubes, the S cubes, and then
yes, the S cubes there. So this one doesn't really mean anything. It's basically it's the same as the asterisks you see in here. For this same book, they have another version. It's the same writers and all that, another version. And for that other book, instead of using the cubes, they use the asterisks, meaning, of course, they support single user or single usage. All right. That is basically what it says. I'm going to put that one also there. So you have, it becomes okay. It doesn't confuse you. All right. Let me look for it. Where are you? Okay. I will just, let me pull on here. So this is the book. Okay, so this is the book. All right, I hope you can see it. See, okay, this is the book there. And you see the asterisks. No explanation is given to that effect, right? Okay, the same people having the same other book, and you also see it here. Instead of having the cube, the raised to the power 3, they have in here as well. Basically explaining that the vendors offers the single user or depending on what it is for that particular thing. I hope that is okay. Is it okay? Can I move on now?
Hello, sir.
Yes.
So you were talking about the extended video, but for that one, it's not on the LMS. So the one that you said you do it and then you upload it on there. So that one is not.
Okay. Okay. The truth is that I am not the one that upload things, the videos on the LMS. It has to be done by the ICDE. And so I've already shared that with the gentleman who is in charge of that. And I'm sure he's working on it and he'll make it available there.
Oh, okay.
All right.
Sure.
Yes.
All right, sure.
Yes. I observed that also for other classes that I've done beyond just teaching the ICDE, I observed that sometimes the recording is long. And when it is long, it doesn't support it being loaded on the LMS. The LMS has a limit. And so that's my challenge. Either than that, I would have been able to put them there as I've been, publishing the other documents, right? So I'm sure it will be handled from that level. So course reps can follow up on such, right? Thank you. Okay, so today, do we have any question from what we did last week? Is there any question again from what we did last week? Do we have any question from what we treated last week, Unit 1? Okay, if there are no questions, I believe we can jump off into looking at what we are going to treat today. Along the line, it may not get interesting. And let me just sound this one ahead of time. Whilst it will look very nice and all that, somehow when we are getting to almost the end of it, it may not look interesting. Why? Because we will start going into the evolution of the data models. And these ones are outmoded. They are not practiced. They are not used now. But just that a few of them, the concept that applies in such is also used in the current database structures that we have. So it may not look interesting at the end. However, we need to know. All right. So for today, as always, for section 1, of course, for this particular unit, Unit 2, it will be introducing you to internal structures of the database system, and then the models used to represent data, emphasis on the models that we use to represent data. So in other words, we can represent data using modeling. We can model our data. And then it will also be explaining how data is organized at different levels of abstraction and how database systems achieve flexibility through data independence, running through to looking at the data models, hierarchical network, and then relational models. There are other ones, such as the object-oriented, and then a few others. But for such, I will not highlight them. I will only mention them in the class. Then also, at the end of this one, you should be able to understand how databases are designed, structured, and accessed. And for key topics that we'll be looking at, we'll be looking at the ANSI SPARC 3 schema architecture, running through to the relational data models. So for this section, we are starting off with the 3 schema architecture. And this section will be explaining how databases are structured into 3 levels. And so basically separating user view or user access, interaction, and engagement from how data is stored on the device itself. So at the end of it, or you should be able to explain the 3 schema architecture. You should be able to also describe those ones, the levels right in there, and then understand how they also interact. But we start off with the 3 schema architecture and how it started. This started in the early 1970s, the early 1970s. And so we had this organization called the American National Standards Institute. In other words, ANSI, Standards Planning Requirements Committee, the SPARC. They defined a framework for data modeling based on degrees of abstraction, data abstraction. Now, realize that we are dealing with something that will be implemented, used across the world. And so if we are going to be dealing with something, there should be some way we standardize our approach and things. For those of you who work in some of these government agencies, or perhaps you might have heard of a body, a government institution in Ghana called Ghana Standards Authority. So what is it? They standardize, things that are manufactured, produced, and things that we use, things that are imported or manufactured from within. They standardize to the level, a certain level, national, and then oftentimes they also would have to agree with international standardization. So they subscribe to ISO standards and a few other standards that are used around the world. If you want to manufacture a vehicle, it should meet a certain standard. All right. For example, if you want to turn right or to turn left, the standards of vehicle manufacturing or production will tell you that there should be something that would prompt other road users of your intention to turn, navigate left or to navigate right. It's a standard. We can also have the same. There's a standard for building. Remember, there's a standard you build. You cannot just start building anything and it will be accepted. No, it needs to meet a certain standard. The same principle applies to how we model our data. Okay, it needs to agree to a standard. And that is where ANSI SPARC comes into the picture, having to propose a framework. In other words, maybe a standard that we also subscribe to, such that we can now model our data. So the ANSI SPARC architecture, as it is often referred to, defines 3 levels of data abstraction. Okay, how data is represented, how data is now presented. It presented in 3 levels. Number 1 would be the external. Number 2 would be the conceptual. And number 3 would be the internal. We are going to explore these ones. The external, of course, so if you want to model your data, it should agree to these 3 different steps. So the external would be addressing how users see, all right, data, how they engage with the data environment. In other words, and I've explained in our previous class, Unit 1, who forms the users. Users can be you and me. It can be database administrators, systems analysts. It can be the database designers. It can be the programmers, okay? It can be other systems that also use, the database. So how other users see view the data environment is the external model or the external component of this architecture. So the term end users refers to people, in this case, who use the application programs to manipulate the data and generate what? Information. So companies, if you observe it in the perspective of companies, institutions, we don't see data the same way. Or maybe let me take it to the broader sense before I come to companies. When you look at Ghana, how Ghana see your data, institutions in Ghana see data is not the same. The passport office under the Ministry of Finance, Ministry of Foreign Affairs, see data, your data, differently from how the police force, our security agencies will see your data. It's also different from how the National Identification Authority sees data, the National Health Insurance Authority would see data, how the Electoral Commission will see data, how the different institutions in Ghana will see data. So if you are picturing Ghana to be one company, let's assume that these institutions I've mentioned will be the department in there. They see data of the same person differently. Bring it down, narrow it down to within an institution. How they see data may not be the same. For example, if you go to Food and Drugs Authority, I don't know if there's anybody that works there, or if there's anybody that can maybe bear witness to what I'm saying. Being a Food and Drugs Authority, being a Standards Authority, or any other government organization, you see that how we see data per the unit we belong to, per the department we belong to, will not be the same. We see it differently. Okay. The organization may see data about a particular person, institution, or client, a customer in a certain perspective, but when you narrow it down to individual department and unit, it will not come the same. So therefore, end users working within those business units view their data subsets as separate from or external to other units within the organization. For example, you enter Food and Drugs Authority right now, and you want to register a product. At the client service, which perhaps may be a department or unit, they will see you as a client coming to register a product. When you transition from that level, and then it gets to the registration department, being it food or drug or household chemicals or any other thing that you are registering with them, they also will see you now to be what? In another way. Then when it gets to those that comes to also do inspection, the inspectorate or enforcement department, they also will see you in another way. So the same person, you are seen differently. We see data about you differently. That is where I want to highlight. All right. The same institution, GCT, we see data about you differently. For example, how ICD sees data about you is different from how accounts will see your data, how exams and records will see your data. All right. How quality assurance maybe will see your data. All right. How even the department you belong to. For example, you guys are under the information technology department. How they will also see data about you. How student affairs will also see data about you. Because remember, I've mentioned about 6 different departments, okay, or institutions, departments under GCTU, but they will see your data differently. It will not be the same. This is basically looking at how each one as users see you. So because data now are being modeled, all right, because now we are going to model the data. In other words, we are going to create a representation of our data, how the data should look like. Okay, let me bring it down. Now, when you have an idea, you want to, a dream house. I believe every one of you have your dream house, right? You have either you are living in your dream house or what you call your dream house today was something that wasn't a dream house, but this is what you can afford. So you are not yet at your dream house. Somehow, the dream house will change to becoming maybe the 2-bedroom now you live in because that is what you can afford. But assuming we all have our dream house, we need to now model the dream house to look real. So the idea is now converted. How you see your dream house will be different from how the architect will see it. So his view is different from your view. We are all users. Your view is different from the architect's view, which will be different from the draftsman's view, which will be different from the foreman's view, okay, which also will be different from how maybe the Lands Commission also sees what data. Is it clear? Does it make sense? Does it make sense, guys?
Yes,
Yes.
sir.
Fantastic. Thank you. So because data are being modeled, all right, thank you for the responses. Entity relationship diagrams will be used to represent the external view. So what we are going to be using to represent how you see data, how I see data, how the others will see data, we are going to use the ERD. Okay, so let's set that foundation. Now, a specific representation of external view is known as the external schema. How it is represented, we can call it what? The external schema. Okay, how you see it. That is the view, the external view. All right, that is the external schema. Now, external schema would include, or how now data will be represented to you would have to include these things. Number one, it would include entities. It would include relationships. It would include the processes and then the constraints imposed by the business unit. All right, we are going to look at them. So let's begin to look at a clear example of how data is seen by two different users. And so what we are seeing here on the screen will be, for example, students registering a course, okay? When you're registering to take a particular course, all right? How you see it will be different from, let's say, how we even schedule the classes. They are not the same. So ideally, these are two separate views that we are seeing, external models for a college or maybe for this university. All right, they are two separate things. A student may take up to, let's say, 6 classes per registration. I don't know how many classes you are taking for this semester. How many are you taking this semester?
7.
7. So in your case, 7. Okay, you have registered for 7. I'm sure you have registered the 7 courses. Have you?
Yeah.
Fantastic.
It's compulsory.
Fantastic. It's compulsory. Fantastic. Whilst it is compulsory, I like the fact that you are stressing it's compulsory. Your colleagues who are taking, who are on the regular programs and all that, some of them don't even see that it is compulsory. Hence, they don't register. And exams time, they come, their name is not on the list. That is a challenge we have been facing. And you are done with, somehow they manage to take exams. You are done with the results. You don't see them on the list. You send your stuff across. And then for years later, when it comes, it is an I. And then they are putting us in a lot of trouble. That is also one of the reasons we have issues with results. It's coming from students. They create some of these challenges for us. Okay, so that is to explain that how, you see, your registration processes will be a view, and then how we also schedule the classes. Like now, you cannot have 2 classes going on. There's one you are taking, another you are going to take after this one. So these are just giving us a view of what 2 different things right now. If we do understand the concept of how we view data to be the very first level, as far as the ANSYS Part 3 schema architecture is concerned, we can now move on to the second part of it. So now we have seen how individually we see data. Okay, but what if now we want to look at it from when we all come together, or how would data look like? And that will bring us to looking at it from the conceptual level or model. Okay, and this represents a global view of the entire database as viewed by the entire organization. So how does GC2 see the entire, data or database? How does the governing organization such as Food and Drugs Authority sees, the entire data by the entire organization? How Ghana sees your data, in as a whole? This is the conceptual, a global view, all right, a global representation of how data is seen. And this is also known as the conceptual schema. Now, it is actually the basics for the identification and high-level description of the main data objects, avoiding database model-specific details. Now, ERD is used to graphically represent the conceptual schema. At least it will give you an idea by now that if the external is given using ERD, pardon me, using ERD gives us the individual view of data. If we want to now look at it, a holistic view of data, then we would have to put them together, and then it forms the global view, which will be all the views that we have individually amalgamated, put together, will present to us the conceptual view or schema. In other words, what you saw earlier, which was the class student registration, and then the class scheduling, these two, observe something in there. You are seeing student, right? Entity called student. Don't worry if you are hearing entity and those things and it's confusing you, because you are going to get to that level to understand. So you are seeing student under the student registration. I want to pick a highlighter. Okay. Do you see the highlighter?
Yes, sir.
Do you see? Fantastic. So this is an entity called student. Thank you. This is an entity called student. Okay. And then the person enrolls in. Okay. So this is also the enrollment is actually an event, an activity, a process. Okay. Then into what? A class. Okay. All right. And then you have been enrolled into a class. This is your class, ICD, your class. I think there are two classes merged as one. All right. Then to this course. All right. Okay. Out of that class, we generate what? A course. Okay. So now let's look at the class scheduling. Certain things would be seen in here, common terms. We are seeing the room. Okay. It's used for a class. So in our case, because it's distant learning, this is the room. The room is the virtual room we are in right now. Okay. And this is the room that we are using for this class. Okay. But remember, there will be somebody to teach the class. All right. And then out of this class, of course, generates what? The course we are doing. So if we want to put the two together, this is one view, and this is also another view. When we are amalgamating them, putting them together, forming that conceptual model, it means we are merging them, put them together. And then when we merge them, we don't need to now repeat the common entities. Are you here with me? You don't repeat the common entities. What are the common entities in these two models? Or what do you see as common? If somebody can answer, you can raise a hand, I'll call you. Do you see anything to be common in both, views? Yes. Justice.
Yes, I think the course and the classes.
Yes, the course and the classes. Thank you very much. The course and the classes. They are the things that are what? Common in these two views. So if they are common, why do you then separate them? Put them together. Remember the issues we have dealt with under the manual file system. Then we came to the computer file system. Then we said we transitioned to the database, right? Then we mentioned from last week that let those issues be a guide to inform how you build the database. So there should not be repetitions unnecessarily. Okay. Hence, these two have come together. So when they come together, you see them now forming this. Okay. You see them now coming together to form this. This gives us the global view of the two different views. All right. If we understand this, it is really going to be a blessing and we can move on. So tomorrow, if you are designing a database for any institution, if you are doing an institution-wide database, you will not be working alone. If you want to work alone, it will be too hectic a job for you because it is too cumbersome. You need to work with a team. You apportion, works and, activities onto them. You do this, you do that. So as they are all handling issues and all that, all right, they would now generate their ERD based on their department they are working with, how they see data, merge them later, bring it together. You all now harmonize your work. That gives you that global view from that institution's perspective. Okay. All right. So with what we have said so far, the global view may present certain advantages. For example, what we are seeing, it provides a relatively easily understood bird's eye. When we say bird's eye, okay, those of you who have done movies before, I've acted before, so I understand. You take a wide view. Like when the bird is flying, it sees wide. It provides a bird's eye view of the data environment. It gives you a wider view of the data environment. Then another advantage that comes in here would be the conceptual model is independent of both software and hardware. It is independent of both software and hardware. Can somebody explain why at this level it is independent of both software and hardware? Yep. Any idea? Anybody? If you can just raise your hand. It's independent of the software or the hardware. Independent. Independent. Is there anybody that can speak to this? Right. Okay. So you see, when we say software independence, all right, what we mean to say is that the model does not depend on the database management system software that has to be used to implement the model. Okay, this is just giving us a blueprint. It doesn't depend. At this level, we don't need to know what specific database management software, system software we need to use. Plus, we also don't need to know what machine. This is not necessary at this level. Okay, all right. Okay, so having known this, also we can move on to looking at the internal. So now we have handled external, conceptual. Now we are the internal. In some books, I must say this, in some books, it will say the physical. Some put the two together as internal and then physical. Others will separate them. However, it still addresses the same issue. Internal. Internal here, once a specific database management system software has been selected. Okay, once we are done, what we now want to select, okay, or choose, what happens is that the internal model maps the conceptual model to the DBMS. It's like now that you have designed the architecture, the drawing of my ideal building for me, the internal model side mimics having to map the drawing on the floor. In other words, we use pegs and then ropes. The ropes that you often will see, if you have not built before, would be the dry line. You know, what we use in a house, where we, after washing, where we hang our clothes on. They normally will use these, but they will do pegging. But before they do the pegging, they will draw on the floor. Okay, draw your architecture on the floor and do the pegs, and then tie ropes around it to now basically draw the thing, bring it out on the floor. So then people can now start digging as they dig. So when they dig, then they will put in some concrete and then erect some blocks on top of it to a certain level, being it, however, depending on your land where you are, maybe 2 inch or 4 inch, as if 4 feet rather, 2 feet or 4 feet level. Then they fill up to form the foundation of the building. Okay, so this is where we are now doing we are building the whole thing on the ground. So we are building the database on the device itself. Okay, so we map the conceptual model, the drawing, the blueprint, to the database management system. The internal model is the representation of the database as seen by the DBMS. So in other words, we are saying that the internal model requires the designer to match the conceptual model's characteristics and constraints to those of the selected implementation model. So it maps the conceptual model to what? The DBMS. An internal schema depicts a specific representation of an internal model using the DB construct supported by the chosen DB. Now, because this course you're doing focuses on relational model, you'll get to see what the relational model is, right? A relational database is chosen to implement the internal model. We are going to be using relational model to implement what? The internal model. So therefore, we are saying that the internal schema should map the conceptual model to the relational model construct. Okay, in particular, the entities in the conceptual model are mapped to tables in the relational model. Are we clear on that one? What we have seen in the past let me go back. These are entities. These are entities. Just take note of what you're seeing as entities today. Tomorrow, we will learn some new things around it. But this is one way to represent them. So student, professor, or lecturer, enroll, class, course, room, they are entities, okay? Now, when we are mapping it to that relational model construct, okay? The relational model, yes, model construct. In other words, we are changing from the conceptual to now represent it to depict the relational DBMS, okay? We will change entities. That term we have seen. From being entities, they become tables. Is that clear, guys? They become what? Tables. Before, they are known as what? Entities. From that perspective of external view, conceptual view, they are seen as entities. But the moment it gets to the internal, it is converted, changed, it transmogrifies, if you want to use that word, from entities to its metamorphosis. Thank you. That's also another word. It's metamorphosis from entity to becoming what? Tables. It's like a larva becoming what? Or a caterpillar becoming a butterfly. All right. Is that okay, guys? Does it make sense?
Yes, sir.
Fantastic. Do we have any question anyway? Do you have any question? There are only a few of you here. Where are the rest? 87 people. Where are the rest? You are more than this. Or they are busy or engaged somewhere. Okay, let's continue. So the internal model is at this level, it is software dependent. I hope that is clear.
Yes,
Remember, at the conceptual, it is just paperwork. It is on the computer or maybe on the paper. It's not dependent on any software or hardware. But if you want to implement it to make it physical, okay, that physical representation of it on the device, this time it is software dependent. So a change in the DBMS software requires that the internal model be changed to fit the characteristics and requirements of the implementation DB1 model. Now, when you can change the internal model without affecting the conceptual model, you have what we call logical independence. So yes, if we can change our internal structure, how it looks like on the physical machine, and by changing that, it doesn't alter, it doesn't change the blueprints, then we have achieved what we call the logical independence. Okay, by changing your physical building, the structure, how you built, okay, by changing it, if it does not come to alter anything on the architectural drawing, for example, you see, for example, some people, instead of maybe building their wall, okay, putting up their wall within the perimeters that they have, that 100 by 70 or 70 by 100 perimeter. Some people may decide that, I don't want to go so close to the roadside. Let me just allow some room in front of me, of my house. Okay, I will not be greedy to make full use of my plot and now still take some government land to now grow some greens. No, I want to rather pull my wall inside, allow the greens to be built in there. So tomorrow, even if they are building road, okay, I've not taken any government land. You see, per the drawing, they have changed where their wall should be, but it does not change the drawing on the architectural drawing. It doesn't change it, but on the ground, it is changed. It doesn't change the architectural drawing. And when that happens, it means that we have attained what we call logical independence. That is what I mean to say, using that to explain that. Is that okay, guys?
Yes, sir.
So Fantastic. Thank you. So what we mean to say by the logical independence is just to say that it refers to the task of creating a conceptual data model that could be implemented in any database management system. Any database management system we can implement. However, the internal model is still what? Hardware independent, because it is unaffected by the choice of the computer on which the software is what? Installed. Rather, remember, it is software dependent, but it is hardware what? Independent. Hence, a change in storage devices or even a change in the operating systems will not affect the internal what? Model. So let's look at how it looks like. Okay. Now, how data
is software dependent.
Sorry, can you mute, please? Let's now look at how now the same data as we have seen individually from the external view, then moving on to how we see globally from that institution-wide view, how the same data is seen now by the device itself. This is how it looks like internally. So the conceptual is now changed. We're representing it on the device. And now what was seen as entity becomes a table. Remember, so internally, we will say create table. Instead of saying maybe create entity, it becomes what? Create table. And the table is called professor. Remember, this is the professor. Now here, it becomes a table. It's no more entity. Entity as conceptual, entity as external, but under internal, it is no more entity. It becomes a table. And so this entity we see that comes, the other things that will come with it, we'll see that later, now becomes a full table that has the name and the table name, then the attributes that comes with it, as well as the other metadata that comes with it. Okay. Is that okay, guys? Does it make sense?
It does.
Yes, sir. Yeah.
Yes, sir.
Fantastic. Fantastic. If there is anything, you can prompt me if I'm moving too fast, if the examples are not clear, or if maybe I'm using too technical words, you can prompt me and then I would just work on it.
Perfect.
Yes,
Thank
sir.
you so much.
Please break down the technical words.
Which one specifically, please? Just help me out.
What you've mentioned. Some of us, we don't understand.
Oh, no, be specific, because if you say all I've mentioned, I've said a lot of things. I will not be able to remember. But if it is something like entity, it's a technical word to you, right?
Entity is a basic word, but some of the words, some of us have not come across.
Like what? Give me an example so I can understand. It will help me, please. Give me an example. Can somebody give me an example? Maybe a term I use that sounds too technical. I want to help. Is there any term? Can you mention any term? Is it the construct I use? Or what? Oh, if you're unable to, or is it the logical or independence? If you don't help me, it becomes too difficult for me to identify which one. Or the ANSI Spark architecture, DBMS, conceptual. Please, I'm mentioning them. So if I mention anything that you think is too technical, let me know. Entity relationship diagram, external view, internal view, conceptual view. Data abstraction. Oh, please help me out. I want to be sure. So
maybe she wants you to go over again. Maybe.
Which side? Which side you feel free? Oh, this is your class. Oh, you are paying me. I hope you know that. You are paying me. So feel free. Relate with me. I'm a brother. I don't do this lecturer students, then I'm separated from my student. No. I want to be so close to my students. I have that bond with my students. Yeah. So please we are helping ourselves in here. So help me, my sister. I don't know who spoke, but if you want to send me a private one, you can go ahead, and then I will just break things down. Or, okay, should I repeat this side of it? Is it just to repeat this side?
Yeah, that would do. So
Yes, sir. Yes.
Okay, thank you so very much. My sister, you have saved a lot of people. Oh. It's good to speak up. It's good to speak up. So you have been bold. You are the Asantwa here. Thank you so much for that. Okay, so let me first of all bring it from the beginning to this end. And going back, I want to start off with the external. You see, I said that this organization called ANSYSPAC said if you want to model your data, okay, everything is modeled, including the house you want to live in. We model it. The car you are driving, it was modeled. Okay. Everything is basically modeled. A few things may not be able to model, but somehow we are building database. It's a system. We need to model it. You are going to do a software, design a software. You are going to model it. And this organization that has come up with a standard that everybody in the world would have to agree to such that today, if I am doing a project with somebody from China, we understand the language we are speaking because we are speaking the same terms. If I'm doing the same project with somebody from Papua New Guinea, it will be the same terms. It will not be different. The terms will be the same. So what are the terms? They are saying that if you want to build a database, or you need to model your data, in modeling that data that you want to now manage within your database, it should go with these three things. External, it should have external model or external schema. It should also have a middle one, which is the conceptual schema or model. Then it should have the last one being the internal schema or model. Now, the external is how individuals will see data. And I use an example of this school. Departments in this school sees data, your data, student data differently. And I have mentioned student. Student is an entity. Student is an entity. We will get to explain entity again. When you go back to what we treated last week, student is a file. Okay? We are building on from what we learned last week. Student is a file. So how they see student, your data is different. So ICD sees your data different from how I even see your data. And so these are two different views. And it's also different from how exams and records sees your data. Again, it's also different from how the account also sees your data. Student affairs also sees your data. So external view gives us how the individual user sees data. When you go, bring it down to a department level, we have units within department. I'm sure the unit will also see data differently. So external view is giving us how user sees data. Okay, and how we represent that will be using what we call the ERD, entity relationship diagram, which I said, don't let it confuse you for now. Just here, maybe put it in your mind that for us to draw how you see data, how I see data, we will need to use what? Use what we call entity relationship diagram. Okay, now, and I'm going to show you an example of such. This here are two different views of data. How you register for your courses, okay? And then how this course is also scheduled for classes to start or for us to hold our classes. There are two different ways we see the same data or we see data, okay? And these are external views. Now, in here, we are seeing students. The student is an entity. I said, don't let it confuse you. We'll get there later. The student is an entity, and row is an entity, class is an entity, course is an entity. Put them together is how you register your class or your course, how you see it. Then how the course now begins or is run is also another view, another way we see it. So these are two separate views of data that we are modeling. Okay, that is external view. Now, when you put the two together, it gives you the conceptual view, which will be the organization-wide entire view of data. Yes, Vida, your hand is up.
Okay, so I just need some clarification on how data is being seen or how it's being viewed. The how, is it where they are going to source the data from, or the channel they are going to source that data from is the how, or maybe the different information that they get from the students is the how?
Thank you so much for this question. I think it's a very powerful question. It makes a lot of sense. Thank you. It will clarify a lot of things for some people. Now, what I say about how we see data, I use some examples. I'm sure you joined in late. I said that data about you, I don't know where you work, but you agree with me that the Ghana Police Service sees data about you different. How they see your data, for example, sometimes we go for, how do we call that? Those of you who are police officers here can help me. You go to the CID for, how do they call that? For criminal something. They check their criminal database.
Clearance form.
Clearance, thank you. Oh, God bless you. The clearance. So that is how the police service sees you. The data, we all have data about us in Ghana. So when they also check their database, have you committed any crime? If you have committed a crime, then they can read it. If you have not committed any crime, there's nothing about you. But there's a way they see you. They know your name. They know your phone number. They know other details about you. That is how the police sees you. But what they see about you will be different from maybe what the National Identification Authority also see. Does it make clear now on how you see the data? Because this is how what they have captured about you. That is what I mean to see. What they have captured about you, the data they have collected about you is what they are seeing about you.
It's clear.
Okay.
Great. Benjamin, your hand is up. Go ahead, Benjamin. Benjamin Arthur, your hand is up. Can Benjamin hear me? Or is it a mistake?
Please, can you hear me?
Yes, Benjamin, we can hear you now. Go ahead.
Okay, so I wanted to ask if we can use the school's LMS as an example.
Yes. I like this one. Thank you, Benjamin. You see, the school system, Okay, you right now, when you go on the LMS, what can you see? For this course, what can you see? Or even beyond this course, when you go on your LMS, what do you see?
So when you enter the LMS, so I was saying we can use this as an example mainly because maybe per the information how everything the data is being displayed to we the student might be different from how the lecturer will see it at his end.
Charlie, if you are around, I would have given you some achumo.
Yeah.
Thank you so much. How you see data on the LMS is different from how I see data. You are only allowed to see what has been published, the courses you are doing. And you are seeing more courses on your LMS. Is that not the case?
So, sir, basically front end and back end.
It's not just front end and back end. That is why I'm saying that. So allow me to explain by also saying that when you are done with exams, you see data different. Your data you see will be all your results for the courses you have done so far. Is that not the case?
Yes, sir.
Yes, sir. Fantastic. But I only see the course I taught you, what I handled of you guys or with you guys. I only see your results. You will see all the results of the courses you took for a semester, and perhaps even see for all the other courses you have done so far in the school. I can only see the course I have taught you. So my view of data is different from your view of data, yet we are seeing the same view. Let's say this course is done, exams is done, and I award marks. You had 80. You had 80. On my list, I see all your results, all the students in this class, your results. That is my view of data. Your view of data will be your only mark for this course and the other marks you have had for the other courses. The HOD will see the results of all the lecturers. And you will see all our results. But I can't see my colleagues' results. I can only see my results. Your view of data, you can't see your colleagues' results. You only see your results. So do you see that we are all seeing the same data, but we are seeing it differently? Is it clear, guys?
Yes, sir.
Fantastic. So the conceptual side is where now we bring together how all these entities, or rather, when I say entities, it will confuse you because it's actually an English word I'm using and not the term in database. How now the department or maybe the unit now will come together and see data. So, for example, the conceptual view of data for us now would be how students see data, how the lecturer will see the data, okay? How lecturers see data, how HOD or the department also will see data, how the account see your data, how exams and records see your data, how student affairs sees your data. When we put all these 5 different departments together, will give us the conceptual view or model or schema, conceptual schema, conceptual view, conceptual model. Is it clear?
Perfect.
Yes, sir.
Great. So I hope there are no technicalities in here.
Nah.
Great. It's clear. Thank you. So now again to say that now the conceptual view, the conceptual view is now the full building, the drawing. I don't know if you have seen a building plan before. We have front elevation, back elevation, something elevation, ground floor, that floor, blah, blah, blah. Do you see that?
Yes, sir.
Those will be the individual views. No, you see, somebody standing at the side, how would the person see it? Somebody standing in the front, how would the person see it? Somebody standing at the side. So that will give us the individual or external views. That is just to use that to explain. Then the plan, the full plan together now will become the conceptual when we put them together. Side view, front view, back, whatever. Now we draw everything on the side, whatever. That document, I've forgotten the name. That is the conceptual. Now, when we translate what is on the sheet, in this case, the conceptual model, to the ground, the system itself is the internal. Now, we are moving it from drawing these drawings to now implementing it on the computer itself is the internal model. Okay, and I said that the conceptual model uses terminologies that would change when you come into the internal application now. I hope you understand what I'm saying.
I'm fine.
Hey, please, we can hear you, Rukaya. I hope you understand it, people of God. You can understand me now. That now, in conceptual, we use terminologies like entities. Okay, entities. But when we are doing the thing on the physical machine, how do you now put up an entity on the physical machine? It's no more called entity. The language it speaks, the term it understands on the computer is called table. The DBMS that we use to now design this thing on the computer is called table. It uses the term table instead of entity. It will say table. Okay, let me ask a question. File, all right? File from what we have learned in the past, computer-based file system. File, entity, and then table. What are the similarities in there? Is there anything you can see with them? File, entity, table. Is there anything you can see with the three things I've mentioned? Yes? Anybody? I've not gone anywhere. I have only done 1 hour, but I have not even finished with section 1 today. Wow. I have a lot to do. And I have 6 more or less than 6 more slides to go for section 1, then I can tackle the others. Yes, please. Yes, let's hear you. Is there anything you see when you can identify with file from computer-based file system we learned last week? Then today you have heard entity from at least what we have mentioned, and table. Is there anything you see with the 3 things I've mentioned? Please, is there anything you see? Nobody sees anything? Okay.
Listen.
Sorry, who is speaking?
It's Vida.
Vida. Go ahead, Vida.
Oh, I think they all store data.
Okay, thank you, Vida. I think that's a good attempt. I appreciate it. You're on point, though. You're on point. Any other person? Let's hear from the men, please. Let's hear from the men.
Sir.
Yes, Hayford, go ahead.
Like to add up to what Vida said, like they store like related like data, which are of like specific subjects.
Okay, fantastic. Thank you very much, Hayford and Vida. Okay, they are the same. They are the same. Hello?
Yes,
guys,
sir.
They are the
Yes,
same.
Yes,
They are the
Yes, sir.
same. In computer file system, you see, we were using file. And remember, we said customer file, student file. Do you remember? Or we have forgotten what we learned last week. Computer-based file system. Yes. Okay, if you have not forgotten, then that is it. And then we're looking at customer, and we even looked at the table, that file. It was a file. And we had a customer name, including even the agent name, the phone number, agent. Do you remember that? Yeah. You see, it was known as a file, and we explained what a file was. Then I said that this same thing you are seeing, as we move along the line, it will change in terminology. So now you have heard it. The file now becomes what? If you are modeling down, the file becomes entity. The file, what you know, the file is the same thing, file. Now it has become what? Entity. And now it also has become what we call table. It's the same thing, table. But we are using it differently. It's like saying a client. When you say a client, who is a client? Depending on where you are, some people may say client, others will say customer. Others will say applicant. The police force, how do you describe us? Do you call us maybe complainants? See, the same things, so the same terminologies we are using, depending on where you are applying it. Complainant, or another will say participant, another will say the ward. You understand? Patient. Sorry? I didn't get it. Another will say patient. Another will say what? What is the other word? You see, it's the same stuff. It's the same thing that we are playing around with. Another will say a friend. Another will say a student. Does it make sense, guys?
Yes, sir.
Great. Great. Can we move on now?
Yes, sir.
Great. Thank you. Thank you for the responses. Okay. Now, having identified these three levels within the ANSI SPAC 3 schema architecture, if you're abstracting it, okay, let's look at it in this level, the three levels, a pictorial view of it. So now, I said that the external view will be the end user view, how we all see data. Okay, the same thing. External. So external model. You will see yours, this person also see. So these people may be representing in department. It can go further down anyway. Then the conceptual model will be the designer's view. The designer's view. So you see it here, it's not how the end users see it. Why should they see it? What have they got to do with how you see your data, and so what? They are only interested in results that have been published. I want to see my results. You are saying I should see what you have published for others. What am I doing with that? I don't need that. Then there will be the DBMS view, which is the internal model. And like I said, in some books, it puts the two together because this is where we are now mapping the conceptual model onto the physical device. Okay, and so in some books, it puts internal as the same as what the physical, right? But in this particular figure, we have extended, or it has been extended with the addition of the physical model to explicitly address physical level implementation details of the internal model. Okay. All right. If we understand that, then we can move on to looking at, okay, now the physical model. All right. But like I said, if you're looking at it, it's only three. It's three tier. Some books will say 3-tier schema or 3 schema. So it's 3 schema architecture.
Hello, sir.
Yes.
You call me.
Okay, go ahead.
You.
Hello, are you there?
So he's not talking to us. Man. It seems like he's making a call.
Oh,
Lawrence, mute your this thing. Yeah, sorry.
So sorry, you confused us. Okay, right, let's move on. So now, the physical model operates at the lowest level of abstraction, describing the way data are saved on the storage media, such as the disk or the tapes, how we store it on the drives. Okay, and at this level, physical model level, is software and hardware dependent. And also requires that the DB designers have a detailed knowledge of the hardware and software used to implement DB design. So at this level, you need to understand requirements, software requirements, hardware requirements. Are you here with me? You need to understand the precision required in the physical model's definition demands that the database designer, which can be you, who work at this level, have detailed knowledge of hardware and software used to implement the database design. So guys, at this level, you need to be very knowledgeable. You need to be informed. You need to know when we say operating system, what it is, the different types of operating systems. You need to understand hard drives. You need to understand memory. You need to understand the processors, CPUs, yes? You need to understand the different cores. When we say processors, the central processing unit, okay? The brain of the computers, the number of cores they have, okay? You need to understand networks, network cards. That is how come your course is structured, that you have fair knowledge of all these things. Why would we need to understand these things as I'm mentioning them or have knowledge about them? let me say this one before I address that. You see, you should not finish the course without being able to even boot a computer, turn on a computer. Or when we say turn it off, you should know how to turn it off. You should know how to look for the drive. You should know how to check the space on it, the capacity of your computer. You should understand these terms. Now, to address the question that I asked, maybe I can throw it back to you. Why do you need to learn? Why do you need to understand, have knowledge about these things? Who can answer that? Why do you need to have knowledge about these things, guys? Why? Why do you think you need to have knowledge about these things? Anybody that wants to share a bit on that?
So can I give it a
Yes.
try?
Yes, give it a try, sir.
Okay. So so as not to put yourself and other people in danger. If I say that, let me set an example of someone working in a data center. And then with the configurations that are done on the data center and the cable, the physical connections that is being done, if you have no knowledge about it and you mistakenly take out a cable, it will put, for instance, if it's a live network you are working on, and you mistakenly take out the cable, it brings the entire system down.
Okay, thank you so much. That is one reason. That is one
Hello,
reason.
sir. Can I come in, sir?
Yes, yes, come in.
So it also helps to expand like the lifespan at the particular thing that you are using. So the analysis that he gave, for example, if you are working on computer, you should know how to put it off, how to put it on. It helps you to also reserve the lifespan of, let's say, that particular computer. Because if you shut it down anyhow, it's going to develop a problem for you.
All right, thank you, Richard. Any other person?
So it saves time
Mark.
too.
It saves time. Is that Mustafa?
Yes, please.
Okay, how do you mean by it saves time? After you, I'll take Mark. How do you explain that it saves time?
Okay, so if you say it saves time, just like you said, you knowing how to turn on a computer or how to turn it off or even how to reboot it. And unlike someone that doesn't also know how to do it, if they ask someone, the two of you to do it at the same time, you that know how to do it will quickly do it than the one that have no knowledge of how to do it.
Okay, thank you. Mark, your hand is up.
Yeah, sir. Okay, so my idea is also, and when you know these basic things, it helps you build an efficient database system. In the case
Go ahead.
in the case that if you are building a database for a smaller organization, the physical, requirement of space or, whatever you use. And also if you're building it for a very large corporation or a government system, so the kind of specific data, the specific hardware you have to use in order to, to accommodate the kind of data you'll be receiving from the end users. Thank you.
Wow. Thank you very much. This is very technical response. I appreciate it. Ebenezer.
Okay, sir, good afternoon.
Good afternoon.
Yes, so for you to know all these things that we mentioned, though they all comprise, we call it as a computer, but the computer is having the hard drive, which has to host the database or whatever software you are designing. So if you don't know the hard drive size, then maybe perhaps a hard drive have a size of 1 gig. Your data capacity is about 2 gig. You'll be forcing to put on this hard drive and to you won't be able to be successful on the database or the software you are trying to develop.
Fantastic.
Again, the computer also has a network that communicate with other computers. Your database must communicate with other systems. So there is inbuilt network software analysis that will allow that communication to happen. So you should also know how the network works for you to inculcate all those software designs and compatibilities in your software, in your system. So knowing all the parts of the computer and their functions will help you to have a general knowledge on whatever you are going to do and be able to serve every area of what the database is supposed to do. Thank you.
Fantastic. Thank you very much. The responses have been amazing. Hey, okay. Dennis, I'll give you the final word. Dennis, I'll give you the final word, then I can move on. Dennis, let's hear you.
Okay, I'll say that if you have idea about storage devices or the other all the devices that they have mentioned in this case, you will be able to manage a database in an institution or in a company.
Thank you. Thank you so much. Powerful responses so far. I appreciate every one of you. Now, let me use this one, maybe an example. I'm going to give you an example to explain it, to maybe sum up everything that have been said so far. Is there anybody that works at Wk here? Wk. Wk. Some years ago, Ghana recorded an incident. I think 7, 8, or maybe about 10 years ago. We recorded an incident. What was the incident? The incident was that they released results. Forgotten which one it was, whether WASI or BC. I've forgotten which one. But when they released the results, you know, parents and guardians, including students, may want to. They are eager to see the result. What happened? That everybody was rushing onto their system. Now, they all rushed onto the system, and then there was a major issue. The system could not handle the volumes that were coming in. So, eventually, people started complaining, calling radio stations. I heard it even on Peace FM. They called the PR for that institution. I cannot be very certain because it's been years. So some of the things may not be accurate. So pardon me on that. But when they spoke with somebody online, the person explained when they did their root cause analysis by saying that they procured a mid-range server. Are you here with me, guys? They procured a mid-range server. For some of us that are not really IT inclined, don't let this scare you. What is a server? A server is a computer. I hope you understand. But it is a high-end computer. Let me bring it this way for you to understand. Your computer is like the is a Matisse vehicle. They use these small cars that they have been using for Uber. The small cars. Those are the Then the server is like Rolls Royce. Server is like, or maybe G-Wagon, the Brabus. Recently, I went to Kwao to preach. When I was coming, despite was behind me. I don't know if he's the one driving, but I think they went there. He was in the Brabus, the green one. At some point, I had to clear off and allow him to bypass me. And I never saw him again. The bad road, no, for him, he sits high. Where he sits, no, and the road, he doesn't feel anything. He's gone. So me, my car, and that car, no, they are not the same. You cannot compare. So your computer is the small cars that we use for Uber, as against a server, which should be a server. Let me use the right word. Should be like Brabus, or should be like the big, maybe a Land Cruiser. Let me use Land Cruiser, for a lot of people know Land Cruiser. Maybe the Land Cruiser V8, huge car like that. Do you understand? So it's a high-end car. Again, another example of technical words. Bread. When you pick bread and you pick pizza or pizza, as we say in Ghana, bread or pizza, as we say in Ghana, they are the same, guys. Are you aware they are the same?
Yes, sir.
Yes, please.
The men will understand it. They are the same. The women will understand, because the women always want, buy me pizza, buy me pizza. What is pizza? Pizza is glorified bread.
Yes.
A bread with stew.
Yes, it has just been glorified.
I'm vegetable.
Oh my goodness. The women are laughing. So when you are forcing us, go and buy pizza. What is it? We can do the same thing in the house for you. Don't push us. Because it has been glorified, the price is different from the one we buy by the roadside. Do you understand? Again, when you pick a teacher in a training from one of these primary schools, whether LA, DC, MA, whatever, and a lecturer from a university, and people of God, these two people are the same. They are all teachers. They are all teachers. I am a teacher. Nothing special. I am a teacher. I'm not special from you who may be teaching in a primary school or a secondary school. We are all teachers. Only that, in my case, they say lecturer. They have given it a very nice name. You are actually what? A glorified teacher. That is all. That is all. Everything about us is teaching. So when we say high-end computer, in this case, a server is also a computer like yours. It has the same things. Hard drive, memory, keyboard. They even will come with, some of them may come even with a monitor. So it's not different. Only that the specs of that one is high. You heard somebody say, let's say you are supposed to put about 2 gig data on it and your hard drive is just 1 gig. It will not fit in. So for these ones, they have big sizes, some of them in terabytes. And now even beyond the terabytes, huge sizes. So WAEC went in for a mid-range server. In other words, whoever did the procurement was not knowledgeable to consider the fact that when we deploy the results, the volumes that will be coming onto the system will be overwhelmed. It will not be able to handle the requests. What is its processing capacity? The person did not check. What is the memory size? Maybe the person did not factor in that. So these are the dynamics. That is how come you need to understand, have knowledge about these things at this level. Remember, is this database you are designing going to be used by a single user? Is it going to be used by multi-users? If multi-user, is it going to be a work group usage or an enterprise usage? Hello? Is it going to be a centralized one or a distributed one? Is it going to be used for what? Daily operational activities, or it will be for occasional usage? If we understand these dynamics, then based on the knowledge we have, it will inform us which one we should go for that can handle the volumes that are coming through. Imagine you have been consulted. Oh, can you design a software? Okay, a software, of course, for a bank, it will use a database. For our what? The deposit withdrawal and all that. If you don't understand some of these things and the pressure start coming on the organization, what will happen? You see problems you create for the institution. Does it make it clear now? Does it make it clear?
Yes, sir.
Good.
Yes,
Good. Thank you. I guess I can move on now. All right. So have what? Knowledge of the hardware and software that you want to use to implement the database design. And then, of course, this is giving us a pictorial representation of what we have looked at: external, conceptual, internal. You see, these ones now, it puts them like that and it breaks them a little down there. What I mean to say, it's just one. So this has the highest level of abstraction, and it's, of course, for end users' view. It's not hardware and software dependent. No. Conceptual will give the global view of data, independent of database model. It's hardware and software independent. At the internal, all right, specific database model is hardware dependent. Okay. And then also when now we are putting direct onto the system, okay. Yes, for that, neither hardware nor software independent. They are dependent. They are dependent on the software you're using. They are dependent on the hardware. So you don't go and give access. Microsoft Access. Remember, you can use Microsoft Access to create a database for an institution. You can also use MySQL to create a database. You can also use Oracle. We have seen all these examples, so don't let it scare you. I even showed you, based on the question that was asked last week, what the cube, the x raised to the power 3 meant. And I explained that before we got to this level. So this shouldn't confuse you. All right? Yeah, so mentioning these names should not confuse you. And I've already explained, if you want to select the type of database to go for, or you should understand we group it by the number of users, the location, all right, among many other things. The type of data it collects, structured, unstructured. I hope you understand that. So this will be the knowledge base you need moving forward, especially at the downside of it, internal and physical application. So this brings us to the end of this section. We have explained the 3 schema architecture. We have described the external, conceptual, and internal levels. We have also explained how these levels interact. And then some few questions for you to try your hands on. That brings us to the end of this section. Any questions so far? Any question?
It's been clever. It's been very, very well clarified.
Thank you, Mark. Thank you. I really appreciate it. Okay. The sisters, are we okay? I'm particular about the sisters because I have a daughter that finished the school, finished the course. I taught her. Today, she doesn't know anything about computers. I'm surprised. We will come down, we will break it down to any level. Sometimes. Anyway. For her, she's a business person, so she won't even apply. Yes, my sisters, Vida and Co. Are we okay?
Yes.
Sir. We're good.
Great. Thank you.
We are cool.
Thank you. Great. There we are cool. Rukaya, you are cool. Are you sure?
Yes, sir.
I hope some of you are not cursing me in
Hello,
your head.
sir.
Yes, Emmanuel.
Please, what are some of the softwares for good database management system?
Okay. Who can respond to Emmanuel's question? Anybody to respond to Emmanuel's question?
Hello, sir.
Yes, go ahead.
For me, I think the good depends on the kind of work that you want to use it for.
Mm-hmm.
But they have some common ones that you can, use in designing your database system. For instance, Oracle, MySQL, Microsoft SQL Server and stuff, and Postgre.
Mm-hmm.
These are a few ones that they are common in the system that you can use to design those databases, depending on the kind of work that you want to use it for.
Right. Thank you so much. Yes, depending on what you're using it for. So we said you select the type based on few things. Number one, it's not just what is good. Okay, how many people are going to use it? What am I using it for? Is it going to be used for operational activities or non-operational activities? Will it be used to inform, management decisions, strategic decisions? So it probably would agree to, data warehousing. All right. Where would it be centralized usage or it be distributed? Now, if you get these things, then you can now go into research which ones to go for. Microsoft will have DS. Oracle may have DS. All right. Then IBM also have DS, the different ones. So this will take us to the different types. Hold on. Let me just see if I can put that one back on the screen. Where are you? Okay. Can you see this?
Yes, sir.
Yes, sir.
Good. So you don't rush to pick anything. Ask yourself the questions around it. These things should guide you. These are all database products you can use. My Microsoft Access. It can also give you a database. I remember where I used to work before, somebody used Access to create a system for us. When the volume started coming in, remember, it supports single user. It supports multi-user, which was fantastic. So it worked well with us internally. But we're using it to collect data, even outside and within. Centrally was good. In terms of operational, it was also good though, because it helped us with the daily work activities. But at some point, it was overwhelmed. It couldn't handle the volumes that were coming. So we had to go in for a more robust one. Hence, we settled for this one. My Microsoft SQL server. Then also another instance for another one, we use the Oracle. Oracle is very also robust. Right. So that is why your knowledge would work here. You need to have knowledge about software, about hardware, and we have also explained software, what it includes. DBMS is part of software. Operating systems are part of software. Applications and utilities are also what part of software. All right. So you need to understand these things. That is why I said you need to have knowledge about these things. Are we clear on that? Can we move on?
Yes, sir.
We have only 30 minutes. I pray that I can do section 2 and finish off. Then section 3 to 6, I would record it as usual and make it available to the guys to load it up for you. Unfortunately, if we don't do it this way, it means we will not go anywhere because I need to take my time. Unlike the other ones here, we can easily rush through, but yours, I need to take my time because you are not physically here. Okay? Okay, so this section, we are looking at the levels of data abstraction. We have already looked at it. We saw a picture where we said the external, the conceptual, then the internal, then physical. We said the two can be put together. All right. So now let's look at these levels. But of course, the unit overview, yes. But today, this section is focusing on hiding the complex database details from users. All right. And explaining the abstraction in DBMS, describing the external, conceptual, and internal, and then understand how these levels interact. Okay. So, of course, when we say data abstraction, in other words, you have heard me say we want to abstract. Data is going to be abstracted. Abstraction level, this, be, that. It is referring to hiding the complexity of data storage and presenting users with only the information they need. So, in other words, when we are abstracting, we want to hide. Let's hide certain details. And then let's make available certain things that it can easily be used related to consumed. Okay. So it simplifies how users interact with the database by number one, hiding low-level technical details. As it stands now, you and me, we don't need to know how your results is stored and how you are even able to access your results. We don't need to. Those are technical something. Let it hide those things from us. It also provides a clear and user-friendly interface. No wonder you can move around and check your results this semester, check your results in the previous semester. All right. Then it allows different users to see different parts of the data. You see yours, your colleagues will see theirs. I see how, my own. The HODs will also see it in another perspective, which I've already explained. An example, GCTU students see only their results on the ERP and not how the data is stored or processed internally. Please, does it make sense?
Yes, sir.
Yes. Yes, sir.
Fantastic. Thank you so much. All right. I'm just going through the chats. I've seen a lot of messages right in there. I wanted to be sure whether somebody put something there. All right. Nothing. Okay. Now, again, going back to what we have seen already, looking at the levels, and we said we have internal. So now I have inverted it. Okay. Yes. So if before, when I started, I said external, conceptual, and internal, it was like an A, writing the letter capital A. Okay. Now, if I'm picking it internal, conceptual, and external, it's like V now. V is like A inverted. All right. So just picking it from the bottom now, coming up. So internal, of course, like I said, some books consider it as physical. Conceptual gives us the logical view, the global view. External gives us the end user view. All right. So the external or physical, what it focuses on is that it focuses on the lowest level of abstraction. All right. And focuses on how data is stored in the system. How the data is stored in the system. But the conceptual looks at what data is stored and how different data are related. I hope this is not confusing us. What data are we storing and how those different data are related. That was when we now connected your student registration with your class was scheduling. Okay. So what data are we storing? We are storing students, we are storing the class, we are storing the course, we are storing the enroll, we are storing the professor or lecturer. Okay. All right. And then how are they related? They are related by course, they are related by class. Is the conceptual. So then it brings them together. Then we come into looking at the external, which will be the highest level that focuses on user-specific views. And I've already explained this a lot. Now, so what will be the importance of data abstraction in database management system? The importance of data abstraction in database management system. Number one, it simplifies database usage. Why are we saying that? Users do not need to understand complex storage or details. You don't need to. So it makes it simple to use. It also makes systems easier to use. Number two, it improves security. Sensitive data is hidden from unauthorized users. How does that come into force? You are not supposed to see certain things from what I am supposed to see. You don't need to see your colleagues' results. Some years back, I think about 3 or 4 years back, I was teaching database and I got to this point. And one of the students drew my attention to something. And it was a mishap in the ERP. Apparently, they could see the results of their colleagues, including even those who were owing school fees. They told me, I quickly paused the course, called the systems unit department in the school, prompted them, and they basically fixed it. And that is because whoever configured it left something unchecked. So to date, now nobody can see, again, your colleagues' results. You can't see your colleagues' results. All right. So you see, security is maintained. Sensitive data is hidden from unauthorized users. Then different access levels for different users. What you have access to is different from what I have access to, and is also different from how the head of departments also have access to. Okay. Then it supports data independence. Changes at one level do not affect other levels. Okay. Physical changes do not affect logical design. Then logical changes do not affect the user view. All right. It also enhances flexibility. Database structures can be modified easily. And that is quite true. Also, new features can be added without disrupting the users. Now, in terms of maintenance improvement, it is easier to manage and update the system. And then also it reduces errors caused by the system complexity. So at this level, it's just another run through to summarize a few things around to help us. So we have looked at explaining the abstraction, what it is, hiding the complexities, and then making available what you need to know and see. And then we have identified again the levels of abstractions that we have gone through, and then what they do, their importance as well. All right, a few things to help you out, and that will bring us to the end of this section. Let's see. Okay, no question. Do we have any question, guys?
No questions, sir.
Fantastic. So this side is not difficult. All right. Let's move on to section 3. Okay, section 3. Where are you? I hope you remember we mentioned something about data independence. So section 3 is now going to highlight what? Data independence. I'll skip the unit overview and the likes. And then this section, what you're going to do so far would be to explain the ability to modify database without affecting applications. All right. And we are going to define data independence. We are going to differentiate logical and physical independence as well. Okay. So what is data independence? When we say data independence, at least your idea about Ghana's independence should help you. Data independence means data is not dependent, right? Data independence. Data is not dependent. Ghana is independent, meaning Ghana is not dependent on. Is that okay? I hope that is okay. We are independent. We have been independent from our colonial masters. So now we are not dependent on them. Is that true?
Yeah, we don't need them too much.
I beg, we do, papa. We are still dependent.
They are capable of managing our own affairs.
Oh, yes, it's true. But we are still dependent. Why? Because today they tell us what they told us now. Or maybe when you have been colonized, it affects the rest of the things around you. Number one, we are still dressing how they dress. And we are speaking their language. So we are still dependent on their language. We are dependent on their governance style. It's okay. Let's move on. That's
So
another thing.
At least we can make our own decisions. So at least
Yeah, that one is debatable, please. That one is debatable. Decision there, we make the decision, but it's influenced by other places. Do you know America influences every decision around the world?
Yeah.
You are independent, though, but America is the one that decides for the world. So what makes you independent?
We too, sometimes they need our help, so we also give them some terms and conditions.
Hey, the independent is just on paper. It's just a
It's
name.
on paper. Don't mind him. It's on paper. You have terms and conditions for America. Who are you? Master, we bent. We always bent. No country in the world, even the Germany's and all these, they bend. America will say, you have increased tariffs on your goods that are coming to my country. Then they will bow. Anyway, let's move on. Very soon it will change. It will be China that will be in control of the whole world. Very soon.
Very soon.
That is why I don't like, but at least we don't speak their language. So when they take charge, and I wonder how we are going to behave. So it's better you should start learning Chinese today. Everybody should start learning Chinese. Let your children learn Chinese. Because when we are gone, they are going to suffer. Anyway, let's come back home to what we are doing. Data independence is an important benefit of data abstraction. We have said it in the past, but let me highlight the fact that it is very important. It's one of the things we benefit when we abstract our data. And what is it? It is the ability to now change the structure of the database at one level, okay, without affecting other levels of the database system. So when I change how it looks like at the conceptual level, and it doesn't affect how it is seen at the external or maybe the internal, yes, data independence is what achieved. So this is the key concept. Okay, this is the key concept of what we call the three schema architecture, the ANSI SPARC three schema architecture, and helps maintain flexibility in database design. So then all over the world, we speak the same language, we understand things the same way. Okay, yeah. What are the different types of data independence that we have? We have what we call physical data independence, and we also have got what we call logical data independence. We are going to explain the two. Physical data independence and logical data independence. Now, let's start off with the physical. Talking about the physical, all right, the physical data independence, this is the ability to change the physical level without affecting the logical level. Who can explain that? You are changing the physical level without now affecting the logical what level? I hope we know what is at the physical level.
Yes, sir. The end user.
No, the end user is not the physical level.
The internal.
Yes, on the device.
The basic structure, the internal, like the basic structure.
Internal, where you implement the thing physically on the machine itself.
Yeah.
So you see that level, when you make a change there, it doesn't affect. When it doesn't affect the logical level, what is the logical level here?
Hello, sir.
What is the yes?
So is it like moving database files from maybe a drive to another drive, maybe HDD to SDD?
Okay, I like this one. You see, this is also a change. We have made a change. Even when we move from HDD to SSD, whatever. Does it change the conceptual?
No.
No.
It doesn't change.
No, it does not change.
It won't change anything. So yes,
because they are moving the same data.
exactly. And we are not changing. It's not changing how the map, or maybe the if you bring it to you looking at your architectural drawing, it won't change. It's like okay, I plan to build on this land. I have 2 flat land there, and I've drawn the thing. Okay, so my plan, I plan that it will be on land A. So now if I change it and I move the plan, the thing to land B, has it changed the plan on the paper for me?
No, never.
No, it doesn't change it. It doesn't change it. So what then can change? What then can change in the physical data independence level? When we change it, we said it doesn't affect the logical. So then what can we change? Said that it will not even affect the logical. We can change the file organization. We can change the index method. Don't let these things be a border. We will get to understand these things later. Though some of them I will mention them in passing what it means. Okay. Like index and all that will be treated later. We can change the storage, just as somebody said about HDD moving to SDD thing. We can change it. It doesn't change anything. We can even do what we call data compression techniques. We can use that. It doesn't change. It doesn't change it. How it is seen globally, the conceptual level, the logical level, it doesn't change it. What remains unaffected? The tables will be intact. Attributes will be intact. Relationships will be intact. I hope you understand what I mean to say.
Yeah, so
remember, yes,
but
go ahead.
Still there's a change.
What change is that?
I mean, physical change.
No. Yes, the physical change here. When we say the physical change, yes, physical change is change, but there's no change in the logical.
In the logical, yes.
Yeah, so I was trying to say, so meaning that the ones that remains unaffected, that is the tables, attribute, and relationship etc., are also part of the logical architecture.
Your question is very valid, Mark. Okay, these same things. Let me get my pen. Okay. All right, these same things, right? This one.
Yeah.
At the logical level, it's called what? Entities. Do you remember?
Yeah, sure.
The attributes are same. It's still attributes. The relationship, we will get to relationship. Will be the same. Relationship, we have 3 different types. We have then we have so one-to-one and then one-to-many. Then we have many to many. We'll get there. Don't let this confuse you. This is supposed to be the things I should have treated today.
Wow.
But if we are not getting there, I'm going to explain so you understand. And when we meet next week and you have a question, you can raise it with me and I'll take my time to explain as well. Okay?
Yes.
Fantastic. Okay, so now let's look at the example. If the database, anytime you see DB in this course, when you see DB is database. Okay, DB means database. If DB changes from sequential file storage, sequential file storage, this is just to explain again this physical data independence. Okay, so when the database changes from sequential file storage to index storage, remember we said something about index. Okay, and then there's also what? All right, so to index, the logical structure, tables, example of a table, student, or maybe lecturer, remains the same. So what we are saying is that when we change from the sequential file storage, what is sequential file storage? When we say something is stored sequentially, it means it is stored one after the other. I hope you understand it.
Yeah, yes, sir.
One after the other. For example, your index numbers. Let's assume the index numbers is what? 100, 101, 102, This is what? Sequential
order.
Sequential what? Order. This is sequential order. Okay. This is sequential. So we are saying that if the database changes from what? This sequential file storage, storing one after the other, to now to index storage. Index storage. I'm going to show you what index storage is.
Index numbers.
No, not to index numbers. That doesn't mean index numbers. Okay. For example, when you are looking for some things, when you're looking for some things, we use pointers. Pointers. Okay, let's say this index number will be at location. Let's say location A. And then this is at location what? C. This is at location what? D. So now when you are looking for index 101, now it is using locations. The index structure is using what? Location. So it will point to what? Location C to look for it. You understand this well when we start looking at database tuning, performance tuning, and those enhancement things. We will learn something about indexing. So when you are searching for, let's say, a product, when you are searching for a student, instead of it going through the list, if you're about 1 million people, going through it one after the other sequentially to look for you. Let's say your index number, you are located on the list. When we check one after the other, you are maybe 9,999 something. You understand? 999,999. That is where you are. You understand? For the system to go through one after the other will take a long time. But when we use index will point to the location where you are. Straight, it will come and look for you. It will come and fetch you from there. This is a way of enhancing your database performance. So for us to enhance our database performance, we change from sequential file storage to index storage. If you are changing how it looks for an item, it doesn't change the tables. They are still students. They are still lecturer. They are still the same. And the relationship that exists amongst them. Is that okay, guys?
Yes, sir.
Is that okay?
Yes.
Great.
Yes, sir.
Great. Okay. Can I move on? Let me clean it. Are you there, guys, or you are bored? I have some few 7
We are
minutes.
right behind you, sir.
Thank you so much. I told you that as we move along, it may not be interesting. So
this is inversely proportional.
Right. So now let's move on to the next one, which would be now looking at, we have seen physical data independence, right? That when we change the physical things at the physical level, it doesn't change the logical level. Okay, what if we change at the logical side, which is the logical data independence? So this is the ability to change the logical level without affecting the view level. So do you see that now it is like, if I change from internal, it will not affect conceptual. Now, at this level, which is the logical, when I change from the logical, it doesn't affect how people see the data. The users
Yes,
what view of the data. Yes, come in, sir.
So with this logical level, initially you gave an example that you were teaching like 3 years ago, and then somebody drew your attention to the fact that the students were able to see other people's results. So you needed to reach out to the people who were handling it. So for instance, my question is, making changes to the logical level change how the student view the entire results like before?
That was not a change at the logical level. It was a change at the physical level.
Okay.
We made a change at the physical level. And when we made a change at the physical level, we are dealing with now conceptual level. It doesn't change how it looks like. The ERD remains the same. The entity relationship diagrams remain the same. It doesn't change it.
Okay.
If you want to apply to this one, it still will not work here because We are not changing. Taking off something on the physical device is not the logical level. The logical level is the entity relationship diagram level, where you students, the student enroll, and then the professor, the class, the course. Do you remember that side? Student registration, and then class scheduling, where we looked at even when your class, together with your teaching, the class scheduling side. Now, when we put them together, that will be the logical or the conceptual. In other words, putting all the different views together. If I make a change, and for example, when I change, let's say when I add new column, I add a new column, okay? Or when I add a new attribute, I create something, a new table. It doesn't affect how the user sees their data. Okay. For example, when we will get to another place, maybe when I'm teaching. For example, sorry, can we meet up, guys? Can we meet up? Your entity relationship diagram, the entity called student, okay? From what we have seen already, it was like this. Then it had student in here. Is that not the case? Do you remember? This side is supposed to be the attributes. In some books, it will have 3 compartments. It may even break it like this. And this side will contain procedures and other things, okay? So this side is supposed to be attributes. Now, for example, maybe you identify attributes 1, 2, 3. Later you came to realize that, oh, I need to capture attribute 4. Does it change this whole thing? Or maybe how this one relates with another entity? No. It doesn't change it.
Awesome.
I hope that is okay.
Yes,
it doesn't change it.
Yes.
It doesn't change. That is what we are trying to say now. Okay. If we understand. So what remains unaffected? Still, how the user sees data is the same. Then application program, how they relate with it will be the same. It is not like the computer file-based system. Do you remember? The computer file-based system, we said it was software, it was data dependent. It was data dependent. And then it was structure dependent. Do you remember? Hey, you have forgotten so soon. Wow. Anyway, I understand. You guys work, and so sometimes, no. Maybe sitting down to study becomes a little difficult. Adelai. Okay, so now let's look at an example. Adding a new attribute like student ID to the student table that had name and course ID. All right. Existing users who only see name and course ID are not affected. They were seeing name and course ID. What they are now going to see will be what? Name, course ID, and student ID. It won't change anything. They are still seeing what they need to see. All right. Does it make sense?
Yes, sir.
So, thank you. So data independence is basically what? Enforced. Now, what are the importance right in here? Of course, there's flexibility. Database can evolve easily. Ease of maintenance. Changes do not require rewriting programs. You see, unlike the computer file system, when you change something, it means you have to go and change programs that could see the past file or that could work with it. You have to go and change everything around it. No. This one, it doesn't work like that. There's also what? Improved performance. Storage can be optimized using a clear example of what? The index one that we just saw. Security. Changes do not affect user views. Okay. It doesn't affect user views. The only thing it comes in to enforce will be you not seeing another person's something, but you still are limited to seeing your own. Okay, so that would answer the question that was asked, so then we don't confuse it. Then finally, there's also reduction of cost. There's less need for what? System redesign. You don't do any system redesign, basically. All right, so that will bring us to this section ending. And a few questions right there to help you. Do we have any question? If we don't have any question, I would rather want to pause, unless maybe you're okay, you want me to take section 4. Then we will have section 5 and 6 recorded and be sent to you. Do you want me to take the section 4 now?
Yeah, sir.
Oh, thank you so much. I appreciate it. Okay, let's move on to section 4. Section 4 is going to be a little interesting. I need you to be up on this one. Okay? Hey, what am I projecting? All right. All right, section 4. We are looking at the introduction to the data models. So now, you have heard me mention a lot of things, all right? Models, data models. This, you need to model the data. You need to model the data. All right, and we use some key terms right in there. Okay, so now let's go into it. So here, at the end of the day, we should be able to define data model, all right? Then we should be able to identify the types of data models, the type of data models. Okay, so just before we delve into that, now when you are designing your database, all right, when you are designing database, the database design focuses on how the database structure will be used, okay, to store and manage end user what? Data. The database design, it focuses on that side of it, okay? So then, database design, what are the processes involved in database design? So when I ask you to design a database, build a database for an institution, what are the processes that are involved? It involves conceptual design. It involves database selection. It involves logical design. It involves physical design. Now, every one of these things and the things that goes on in them. For example, at the conceptual design level, this is where you bring to bear. Have you guys done systems analysis and design?
Yes, sir. Yes, sir.
Fantastic. So your knowledge, thank you, your knowledge of systems analysis and design will come to force here. It will be needed here. Why? This is where you do data analysis and requirements. Data analysis and then what? Requirements. From there, in the conceptual design, we can now would have, or maybe the things would be, so okay, let's put the activities. Look at the activities on the side, right side. You determine end user views, outputs, and then the transaction requirements. This will help you. You're going to get at these things, okay? Then out of that, you see that we will define the entities, the attributes, the domains, and the relationships. The entity relationship. I want to be sure whether you see me when you see my thing when it moves. The entity relationship modeling and normalization. After we have done the data analysis and requirements, next will be entity relationship modeling and normalization. We will get to understand what it is, but don't worry. We will define the entities, attributes, and the things there. Then we will now do data model verification. At this side, we have modeled. You see, that is the entity relationship modeling. So we have modeled the data, but we need to verify what we have modeled. Verify it with the users to be sure. Then we also will look at a few things that may have to be considered. Define the DBMS and data model to use. Then maybe we will select the DBMS, determine the DBMS and data model to use. Okay, still under that side. Then the logical design will come in, where now we are going to map what we have designed onto the things. Okay, let's move on. I just wanted you to understand that side of it. Okay, so on the case of the data modeling, all right, on the case of our data modeling, right, here is the case. Oh, let me just mention that data modeling is the first step in designing a database after data analysis and requirements have been gathered. So after you have done your systems analysis and design, in this case, data analysis and requirements, you have gathered them. The next thing you do will be your data modeling. And so I'm going to walk you through some of these things. Later, we will come to understand how do we even model the data? Where do we get the things? Okay, how do we go around it? By now, your knowledge of systems analysis and design will be needed here. It will be so much needed here. Now, what is data modeling? It is the process of creating a data model for the data to be stored in a database. So that data you want to store in that database, create a model for that data. Create a model for that data. A model that is accepted internationally, that can be used, a standard that can be applied. I hope you understand. Some people will draw their building plan or see a building plan from US, Canada, and then they may also want to build it here. It works. It works, though there are certain exceptions to that effect, but all things being equal, it works. It's a plan, it works. Do you remember we have heard reports of Ibrahim Mahama saying that he has tasked or he has consulted the sports minister to pick the blueprint of the Boston Stadium. So then he will build one here in Ghana. Have you heard of that?
No, this is the first time I'm hearing it.
Oh yes,
Oh,
yes.
me,
I
I
mean,
read,
this
yeah.
Yes, I heard it yesterday.
Yeah, me too. I read it yesterday on Facebook. So you
Wow.
see, yeah. So you see, now no, he want to model the same building here in Ghana. I hope you understand. I just want to just use it to explain. So the building is what he want to model. The data is what we want to store. So the building is what you want to now put here on the ground in Ghana. I don't know where. All right. So the data modeling helps us to now create that data model for the data to be stored in a database, i.e., a conceptual representation. So when we say you are modeling data, you are basically doing the in the three schema
Abstraction.
architecture. Yes, you are abstracting, but in the three schema architecture, which one exactly are you tackling? In the three schema architecture, which one? Which level is data modeling?
The first one.
No, the first one is the external.
External, yeah.
It won't be at that level. Who else can try? Who else can try? If it's not the external, then what else? What other thing can you think of? Okay, let me just help because of time. It is the second one, the middle one, the conceptual one, the logical one. I hope you understand me. Yeah.
Yeah, yes, sir.
Oh, yeah. How could you have forgotten this? The first side will be when you break them apart individually, how they see it. But now, if we want to model and we put everything together, so this will be at the conceptual representation or conceptual level or schema level.
Yeah.
All right? Yeah. So i.e. a conceptual representation of data objects. Of data objects, the associations between the different data objects. In other words, it will be the relationship. That's what we are talking about, the relationship. Okay? Then, or maybe let me explain. How am I associated with you guys? I'm teaching you. If we are we can model what is going on right now. Lecturer teaches what? Database concept. You can also reverse it. Database concept is taught by maybe me. We will get to that side also one day. Then the rules would be the constraints, the things, the measures we put in place. We'll get there. Okay. Data model is a relatively simple representation, usually graphical. So when we say data model or we are modeling data, we are just designing a graphical representation of our data. So that complex real world situation, a school or a hospital, 37 military hospital, how do we model, how they attend to, patients? How do we model that? That is a real world complex situation that goes on. We can model it by looking at how clients come in, how doctors see them, how they are admitted to the ward discharge. When somebody dies, how we handle it at the morgue. When somebody comes to give birth, you understand? When somebody is just coming for to buy an item from the pharmacy or something, it can be modeled. I hope you understand what I'm saying. And by doing this, we give it a graphical look, a graphical representation. So you can basically walk through and say, oh, from this is what happens. Oh, okay. This is where they go to. This is what Is it clear, guys?
Yes, sir.
Yes, sir.
Fantastic. Thank you. So data modeling helps in the visual representation of data and enforces business. Again, I'm introducing a new term. Please pay attention to this one for me. Data modeling helps in the visual representation of data. It helps with the visual representation of data. And then, so yes, it helps with what? Visual representation of data. That is one. Number two, it enforces what we call business rules. Business rules, we'll see what it is. Regulatory compliances and government policies on the data. On the data. We will see some of these things and explain them. Data models ensure consistency. So this is what ensures that there's some consistency around the world. If I pick the same design and if I go to the Arab world, they understand. If I go back to your country, they understand. If I go to como estás, the Spanish-speaking places, they also understand because we are speaking the same terms. So data models ensure consistency in naming conventions. We'll see that. Default values, semantics, and security while ensuring the quality of what? Of the data. Okay, let me erase this one and move on then. Any questions? All right, so data modeling tool is something that is iterative. Okay, it is iterative, progressive process. It is iterative, meaning that you do something again and again. Typically, what we call the repetitive cycle. And why do we do that? We do it repetitively and then to what? Improve a process or refine a product. I hope that is clear. I hope it's clear. So when we say that we are modeling data, we don't do it once and we end there. No, you do it continuously till you get the optimal one, the best. Okay, right. So you start with a simple understanding of the problem domain. You go to that organization, you go to that department, understand their problem. And as your understanding of the problem domain increases, so does the level of details of the data model. Because if you don't understand, how do you model? I don't understand how the police system works. How do I build a system for the police? You want to build a system for the Ghana Port and Harbor Authority. Okay, import and export. You don't understand how it works. How would you build for them? But when you get to understand, then it will help you with how to even model the data for that system. Does it make sense, guys?
Yes, sir.
Thank you very much. Oftentimes, you get people assuming. We only assume. We assume. It doesn't work like that. For example, if I ask you to build a database for an institution, some of you would assume, oh, yeah, this is how they do it. No. It doesn't work like that. Don't assume for institutions. Go there. Familiarize yourself with how they do things. Ask some questions. Engage people. Interact. Question people. Observe. The terms I'm using right now, does it make sense to you? Where did you hear these terms from? Do you remember? Sorry?
System analysis and database.
Fantastic. Systems analysis and design. How do you get to understand the problem? How do you get to? You need to go and observe. You need to go and what? Ask questions. You can do questionnaire. You can also engage them. Interview people.
Yeah.
You can observe.
Yeah.
So you can appreciate what you are dealing with for them. Okay. When done properly, the final data model is in effect a blueprint. Do you remember I said conceptual gives you a blueprint?
Yeah.
Exactly. It is what? A blueprint containing all the instructions to build a database that will meet all end user what? Requirements. So if I take it to any place, if only it agrees with their terms, it will work. The blueprint is narrative and graphical in nature. That is where you see the different entities and then how they relate with each other, and then certain constraints that are placed on them. You see them. These are technical words. If you think it is, don't worry. We'll see them later, but just get to understand it. And I want to believe that from what I've explained, now it is clear. It doesn't look too technical and afar off. So tomorrow, when I use it again, you should be able to relate with it. Is that okay?
Yes, sir. Very okay.
Thank you. Now, these things, I will not explain them. I'll just hit them and move on because they are self-explanatory. For example, what are the importance of data model? I believe if I leave it for you right now, if I had not even put it on the screen, some of you would have said some things. You understand? What are the importance? The data model provides clear structure. Yes, it improves data quality and integrity. It also reduces redundancy. You remember, these people are collecting this data about you. That person is collecting data. Now, if you are modeling it, remember at some point we will harmonize it. So we don't need to now be repeating some things at A and B or C. It enhances communication. So users can communicate with what designers and application developers. There's that agreement. It's a tool. It also supports efficient database design. It facilitates system development. It enables scalability and flexibility. If you want to blow it up, introduce some new things, or maybe reduce the scope, you are flexible. You can easily do so without any challenge. It also improves security planning and then saves time and then cost. All these things are explained right in here for you. Okay, they are all explained. Unless maybe there's something that you want me to tackle or to explain further. Provide clear structure is there. Improve data quality and integrity. Of course, that is where it defines some constraints. We'll get to understand these things later. Don't worry your head over them. Primary key, foreign key, validation rules. Don't worry. But of course, we will get to understand. Then it reduces redundancy. It eliminates duplicate data through proper design. And that is where normalization comes in. It also enhances communication. It provides visual representation. Helps developers, analysts, stakeholders understand the system. Then, yes, who is it?
Hello, this.
Yes. Mark?
Yeah. Oh, sorry.
Oh, okay. I can end it here because I know I've gone beyond my time. So if you want me to end it, I would record the rest of it and then push it across to you. I mean, they will make it available to you. Okay. Because I know you are supposed to enter into another class in the next couple of minutes. So if you want me to end it here, so then you can take a breather before your next class, else you'll be taking too much info inside. All right. Is that okay?
Yes, sir.
Yes, sir.
All right. Thank you very much. I really appreciate your time. And I want to believe that I didn't bore you. I want to believe that I made it clear and good. And though I don't see you guys, but I love you all. Thank you so much. I'm open for any suggestion,
We love
any
you
prompt.
We love you. Let us see your face, please.
We love you.
Oh, but thank you. But I thought you have already seen my face.
No, I didn't see.
You didn't see?
No.
Oh, then go and look for me. Go and look for me. Go and look for me on Facebook.
We want to see it again.
Oh, unfortunately, where I am behind me is
That your words even encourage us.
Hey, we thank God. We thank God.
Hello, sir.
So what do I do?
So
Yes.
seeing your face will do more.
Hey, Jesus is Lord. Wow.
Put
Let
your
me see
picture in the chat.
my picture in the chat. My picture in the chat. Where can I pull one right now? Let me see. David, are you here? Is it David? Course rep.
Yes, please, I'm here.
Please go on my profile and then pick my picture and put it right in there for them, please.
Yes.
Okay, then I will send your video to them.
Hey, my video. Which one?
The one that you were doing. Yeah,
my 10th anniversary?
Yes, please.
Oh, yeah.
So that they can come and join and then be delivered.
Oh, sure. It would be nice to have you guys come anyway. It would be nice to have you guys come. I'm celebrating my 10th anniversary on the 19th of July. So if you are free, you can come around. It will be at 2 p.m. 10th anniversary, my ministry. I told you I'm a pastor,
Location.
right?
Yeah, lovely,
Oh,
lovely,
okay.
lovely.
Yeah. East
Location.
Legon. East Legon,
Okay.
at the Chartered
Oh,
Institute of
okay.
Bankers on the Trinity Stretch.
Oh, okay.
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 Yeah. Yeah.
Then pass
Some of
it.
you have not sent me
Impossible.
direct message. That
Well,
is
this
how
one,
come.
no wonder, no wonder.
Oh, why? Why no wonder?
Because the way you treat us is different. It's kind of different, big Chaka. So you say
That's
that,
good.
you say it all.
It shows that you're a man of God.
Yeah, I am. I
You
am.
can feel the pastoral qualities in your delivery.
Hey, thank you.
Others are not
All
like
right.
that.
Wow, I see. What is Mempassem?
Oh, we've seen you now. Lovely.
Is the name of the area where your church is located?
Oh, no. This is just a location I'm using for the program.
Oh, okay. Oh, okay.
But of course, yes. Who said
Oh,
Is there
sir,
anything?
we know this face. We know the face.
You know
On
the
social
face?
media. Yes, sir.
On social media? Why, have I preached in your church before?
Christian. I'm not a Christian.
Oh, it doesn't matter. But I move around a lot. I go to
No,
I
when
do
you
a lot
asked
of
whether you preach in my church before.
Oh, okay. But I move around a lot. I do a lot of missions in the northern side, Savannah, and all that. I send clothes, shoes, I send doctors, and I send medicines and things there.
Ah,
Yeah,
That's lovely.
That's
I move around a
pastor.
lot. All right. So I'm available. You can link up anytime, any day. I am a brother. I am not
So
a lecturer. Consider me as
we
a
that
brother.
you also need the gigs. Gigs too. You can come and see you.
I'm available, sir. Anytime, any day. You can connect. You have my phone numbers. It's in the course outline. So link up. You can call me. You can WhatsApp me. I'm available. All right.
Some
I'm
of
on
us,
campus, right?
some of us need deliverance.
Eh.
So we'll be coming.
Oh, okay. Okay. I'm on campus right now because we are having the AGCM inauguration tomorrow. I'm one of their patrons. So I'm with Assemblies of God anyway. So yeah. We are doing
Judith.
the one saying Judith needs deliverance. You don't need it.
Casting, it's castings.
All right. So tomorrow we are doing the inaugural ceremony here on campus at 2 p.m. If some of you are around, you can pass by. All right.
Okay.
Okay. Have a wonderful day today. And we pray that Ghana, as to whether we win, we draw, we lose, whatsoever, we have qualified. So
Amen.
We don't care.
Amen.
We don't care.
Ghana 7.
Yeah.
Ghana.
But I would wish that we score them so then it will help with our ranking around the world.
Yeah, like three.
Let's score them to silence some people.
Seven.
Oh, you know,
Yeah.
7. You know, 7 is not realistic.
Hey, it can be realistical. It's football.
It's football. Yeah.
Hey.
Even the England game, technically, England game, we had a penalty. They didn't give us the penalty.
Yeah, very true.
So we should have scored them. The thing, they tied our hands behind us. We understand. It is well. Okay, guys, God bless you. I'll do the recording and I'll make it available. Okay, I'll take it on from where I left off right now and I'll make it available. Have a wonderful day.
Hallelujah.
Right, we really appreciate.
God bless you.
Hallelujah. God bless you too.
We now get the application idea of what we learned in the other lectures, system analysis.
We see.
Yeah.
I see. That's good.
Well, at first it was like we're seeing shadows and stars.
Now
we are seeing the light.
I see.
The end of the tunnel.
We thank God. Charlie, big ups and have a wonderful day. Bye for now.
Same, sir. Bye.
Yeah, may yours be better. May yours be better.
Amen.
Peace, one love.
All right.
Rasta.
Rastafari.
Oh,